Well, there's a few different strategies. Early in the season, it's pretty much that if you've got any backward areas, if you've got any bits of a field that are thinner, then really we want to say, well, we don't want nitrogen to be limiting in that particular area, so we're going to apply higher rates of nitrogen onto the backward area, the thinner crop, because we want to either encourage tillering at the beginning of a season or just encourage general plant growth, so we can get that crop up to a stage where it's going to reach a higher yield potential. Alternatively, on the thicker areas and early in the season, we definitely don't want to be over applying there. That's just going to lead to too many tillers or too thick a crop, and that's going to lead to lodging problems and higher disease pressure. So early in the season, more on the backward, less on the very forward. Later in the season, we can pursue that type of management strategy, or we can have an option to be a bit more flexible in that if we recognise that there are poor areas, so let's say you've got a poor area earlier in the season, you put more nitrogen on it, it still hasn't really grown later in the season, then we can make a decision that nitrogen's not the problem there, so we don't want to plaster more nitrogen on, we can actually cut back because we're not going to get a cost benefit for putting more nitrogen on that particular area of the field. And also, if we've got to a stage where we're past the sort of lodging and a high disease risk, then we can actually, so talking about the third application, we can actually think about, do we want to actually increase nitrogen on the areas which are potentially got a high yield potential, okay? As long as that extra nitrogen goes into yield and goes into grain and has a direct effect on the bottom line and doesn't go into just increasing the canopy size, then that can be a useful management tool later in the season. So we've got a few options which we can actually adopt. It's in general, I'd say though, what we're looking to do with these management techniques is get a yield response. That's what we're after. We're not necessarily looking to cut back on our nitrogen usage, although it may be that is an associated effect. But in general, we're looking to redistribute our nitrogen and to use our nitrogen more efficiently.
So it's actually just being smarter with my fertiliser and smarter with my nitrogen than I have been in the past, and that's what this is all about.
I think that's the way you can look at it. Yeah.
Okay. So is there any other way in which I can manipulate growth?
Well, once we've been monitoring the canopy, we can then actually think about using things like PGRs, plant growth regulators. So again, on the thicker areas of the field, another way of manipulating that canopy is to increase the growth regulator on that particular part of the field, and indeed to reduce it on areas where you wouldn't want to put high rates of growth regulator on. So reduce on the thinner areas, increase on the thicker areas.
Okay. So how then do I judge if the crop is too thick or too thin?
Okay, that's a good question. First of all, we need to actually. A good idea is to actually try and quantify how much crop we've got there. So rather than just saying we've got a thick crop there or we've got a thicker crop there and a thinner crop there, can we actually measure it? The way we'd actually measure the canopy is by assessing or measuring the green area index. Okay, so you can either do that visually or with digital photographs, or you can use a leaf area index meter. And that actually tells you the actual size of your canopy, rather than just bigger and smaller. As to where do you increase the nitrogen, where do you decrease it, there's a couple of methods that are used. The first is one which compares each part of a field with the field average. Okay, so if we scanned the whole field, or if we monitored the green area index for the whole field, we'd have the average green area index. Part of a field would be below that average, and there we would increase the rate. Part of a field would be above that field average, and we would then increase, cut back the nitrogen rate. That's then benchmarked against an internal reference point, the field average. What we can also do, if we do a measurement of green area index, is we can compare each part of a field, not with the field average, but with an external benchmark. So, for example, the HGCA canopy management guidelines, winter wheat growth guidelines. What they do is they give us a benchmark leaf area index, green area index, for each growth stage of the crop. So, for example, if I want to apply my first application, growth stage 25, mid-tillering, I could look up and I could see what the target green area index is. I would then see that parts of my field were either on target, so that's fine, or they might be above target if they were thicker than the benchmark or more forward than the benchmark leaf area index, so in which case I would reduce my nitrogen rate, or they might be below the target leaf area index. In that case, I would increase it. So you've got two ways of doing it. Either compare it, each part of the field to the field average, or compare each part of the field with an external nitrogen model.
So what would this look like on my farm? How do I go about getting this sort of information?
Well, you start off by initially getting your, you need to, as we discussed, monitor the crop through the nitrogen season. Okay, so you start off with an initial imagery, if you like, or some way that you've collected the information. And this particular example was taken before the first nitrogen application, so our leaf area index scores, you can see on the left-hand side, they're quite low, as we'd expect, coming out of the winter. But what we've got here is a fair bit of variation. We've got a high green area index, which is shown up by the dark green areas. Okay, that's the thickest part of the crop. And that's running through the sort of central, diagonally through the centre of the field. At the top of the field, we've got a low green area index there, that dark red area. We've also got another one down the bottom of the field, which is another low or more backward crop. And then we've got a few orange dots across it, which are a little bit behind or in between. So that's showing us our variation. And then what we've done here is we've applied more fertiliser on those dark red areas and less on the green areas. We've done that through the season, and then what we can then do is we can have a look at the canopy managements at the end of the season. Yeah, so this is taken off. This is an image which was acquired after the last fertiliser application. And we can see now we've got higher figures there of going up to 5.3 green area index. And what you can see is that in general, the bulk of the middle of the field, that's more even. That's a more even, generally more even colour. At the top of the field, that dark red area has gone, the northern tip of the field, so we seem to have benefited from applying more nitrogen there. We've got a more even canopy if we're not over-applying on those dark green areas, and we can see because it's up at 5.3, that's probably about right for May. Our optimum, our highest green area index we want to get up to is about 6.5, so we're looking good for that. There are a few areas, though, or one area in particular down the bottom, where we haven't removed a poor area, okay? And that's basically telling me that the problem here is not nitrogen, so we need to go in there, have a look at it, and make sure we do know what the problem might be. Acidity, might be compaction, might be any number of things down that bottom corner of the field. There's a few orange patches as well. Okay, they're not quite as high yield potential as the dark green bit of a field, but they have responded to nitrogen, not quite to the extent of other parts of the field. But in general, we're looking to get a much more even crop by our nitrogen management responding to differences in the canopy.
So how do we go about getting these maps?
Okay, well, whichever method you use, they've all, essentially there's images which you can get from satellites, there's images which you can get from cameras which are mounted on two-seater aeroplanes, aerial photographs, and they're tractor-mounted sensors. They all do the same thing. What they're looking to do is measure reflectance from the crop. Okay, so most of them will use, or majority of them will use natural light, and they'll measure the reflectance of the natural light off the crop, and they can break down the wavelengths that they actually are looking at in the reflectance characteristics, and they can recognise what's a good healthy crop, what's a bit of bare ground, and whether there's more and whether there's less crop. Then by putting on some sort of calibration procedure, either by ground truthing or by looking at the field average, they can convert that into some sort of index of actual green area. So all the systems use similar-ish technology, but you can get satellite and you can get tractor-mounted sensors.
What's the difference between those two?
Okay, well, if we just listed the main differences here. Satellite, obviously, long way up in the sky. It's got a big field of view. It looks down over a large area of the country. A tractor-mounted sensor, very close to the ground, looks down at about a 2-metre swath of your crop as it's travelling up and down the tram line. The satellites, the resolution's relatively large. Between 10 to 32 metres. What that means is, depending on who you get your images off, it will average a 10 by 10 bit of your field and give you an average green area score for that particular area of the field, or a 32 by 32 metre square. Okay. Tractor-mounted sensors, as they go up their tram line, they'll be recording information quite quickly, and therefore they get a lot higher resolution. So in that 2-metre swath, every half a metre, you'll get another bit of information. Satellites can get affected by cloud. They're an optical system, so they can't see through clouds. So we need to be thinking about how often we want to actually get the satellites imagery. You might be on a 3-split system, so you want to make sure that you get at least 3 images through the season. Tractor-mounted sensors, depending on whether they've got their own light source or not, they can be affected by cloud to a lesser and greater extent. When the satellite comes over, okay, it's like got a memory, like a digital camera, and it has to download that, and that takes a bit of time, and then it has to be processed. So you've got a delay of about 48 hours from image capture to field use potentially, whereas a tractor-mounted sensor will sense out the front and process on the move. How's it used? Well, when a satellite image is processed, that allows it to be benchmarked against an external calibration like a leaf area index, okay, and before it's turned into an application map. The tractor-mounted sensor, it will benchmark against the, because it's a real time, it has to benchmark against the field average as it's recording it before it actually varies nitrogen application on the move.
So what will it look like on my farm? What processes have I to go through to get these?
So a satellite system, satellite image there on the left, each one of those yellow dots is your farm. Within that farm you'd have given me your field boundaries. I can then cut that out from the satellite image, calibrate it against some in-field measurements, and then actually produce the green area index map showing me the differences in the canopy size. And then that then is converted into a nitrogen application map. So the red area, for example, down the bottom of that field will be getting a higher rate of nitrogen shown by the darker blue on the application map on the right-hand side there. So it's a 3-stage system.
How does the tractor work in a similar sort of way?
The tractor does work in a similar sort of way. You can see the blue sensor on the top of the tractor there. It's sensing either side of it. Again, it needs to calibrate the information and turn it into an application map. So it's still a 3-stage system, but done on the move there to produce the application map.
Right, that was a bit quick. Can you show me that again? I missed that.
Okay, so if you look at the actual, you can see the area of the crop that the tractor's sensing, either side of the tram line there. That information will then be processed. As he goes through the field, he collects information on about the average biomass of the field, increases and decreasing it depending on what the field average is it's actually recording, and then we can see the differences in nitrogen rate based on the crop biomass.
Right,